Life in meteorite. How life originated on Earth is a question that people have pondered for ages. Theories abound, from those based on religious doctrine to the purely scientific, to others that bordered on science fiction. One possibility that hovers on this border is the panspermia theory, which suggests that life on Earth did not originate on our planet, but was transported here from somewhere else in the universe. While this idea may seem straight out of a science fiction novel, some evidence suggests that an extraterrestrial origin of life may not be impossible. In 1996, NASA scientists announced the evidence of what is claimed to be bacterial fossils in meteors. They put the famous meteorite Allen Hills 84001, which was discovered by a team of US scientists in Antarctica in 1984, under a scanning electron microscope and saw what appeared to be nanoscale fossils of bacteria-like lifeforms. It is estimated that the meteorite formed on Mars about 4.5 billion years ago and was ejected into space much later, about 15 million years ago, when a large meteorite likely struck Mars. It then landed on Earth about 13,000 years ago, after spending most of that time traveling throughout the solar system. If further confirmed, the fossil would be the first true evidence of extraterrestrial life, a strong evidence to support the panspermia theory. Even if extraterrestrial life did exist, proponents of the panspermia theory must still determine how life arrived on Earth. The best candidates to act as seeds of life are bacterial spores, which allow bacteria to remain in a dormant state in the absence of nutrients. Bacteria constitute about 1/3 of the Earth's biomass and are characterized by their ability to survive under extreme conditions. Those that we initially believed were unable to support life, some bacteria, for example, can grow at temperatures as high as 113 degrees Celsius. In light of panspermia, the important question is if bacteria or bacterial spores could survive in space. To address this question, scientists at the German Aerospace Center in Cologne designed experiments using the Russian PHOTON satellite. They mixed bacterial spores with particles of clay, red sandstone, Martian meteorite, or simulated Martian soil to make small lumps a centimeter across, which were then exposed via the satellite to outer space. After 2 weeks of exposure, researchers found that nearly all of the bacterial spores mixed with red sandstone were able to survive. Another study showed that bacterial spores could survive the extreme conditions of outer space for 6 years if they were protected from extraterrestrial solar UV radiation. This would be possible if the spores traveled within comets or meteorites. However, interplanetary distances are large, so the time a bacterial spore would have to spend in a meteorite or comet before hitting a host planet could range in the millions of years. 2 studies involving the isolation of bacterial spores, either from the abdomen of extinct bees preserved in amber or from the brine inclusion in an old salt crystal from the Permian Salado Formation, suggest that bacterial spores can remain viable up to 250 million years, making bacterial spores potential accountability for life on Earth even higher. At present, with the development of technologies, further studies are being carried out to discover more on the life and survival rate of bacteria both on Earth and in outer space. Yet, a recent experiment has dealt a fatal blow to this theory, because it showed that these seeds of life couldn't survive the extreme heat on entering the Earth's atmosphere. Scientists at the Center of Molecular Biophysics in Orleans managed to simulate a meteorite entry by attaching some microfossils as well as rocks that were smeared with a hardy bacterium called Crocococcidipidus, supported to resemble a proposed germ on Mars, to the heat shield of a returning Russian spacecraft. After the spacecraft was retrieved, the microfossils survived, but the Crococcidipus was burned black, although their outlines remained. Scientists then suggested that traces of fossil life contained in Martian sedimentary meteorites could not be preserved when they reach the surface of the Earth. However, at least the 2 centimeters of rock is not sufficient to protect the living organisms during atmospheric entry.